Video journal Math Concepts Vocabulary is with you. Today we will talk about patterns and formula. Well, academic freedom at work, so any episode may include but is not guaranteed to have math and jokes and illustrations, and no offense is intended, so proceed at your own risk. Disclaimer, no math professors were physically harmed when preparing this series. Sorry if you hoped otherwise. Let's talk about formula. And God created numbers, and he created math, and it was good. And then Satan said, let's add letters to the numbers. And there was algebra, and there was calculus. So, our brain is good in catching patterns. Let's look at the following patterns. Y is equal to x minus 5. Or y is equal to minus x minus 12. Y is equal to 0.5 times x. Y is equal to 100. Do you remember anything about these expressions? Do you recognize that that would be an equation of a line on xy plane, right? So it will be, so how does the pattern go there? So each of these equations would denote a different line, right? Okay, so this would be a line and it's written in the slope-intercept form, right? So here the slope will be 2, the intercept with y-axis will be minus 5, right? So when x is equal to 0, y is going to be minus 5, right? Here the slope is negative 1, here the slope is 1/2, and here what is the slope? It's actually 0 times x, right? So the slope is 0. What does it mean the slope is 0? It means that this line is parallel to the x-axis, and that is also a constant function. So if you consider if this is f of x, whatever x is, f of x is 100. Okay, so how would we write down a pattern that corresponds to an equation of a line on xy plane? Something like this. Y is equal to a number times x plus a number. Well, it looks good, but it may be confusing. It looks like maybe this number has to be the same as this number, and we know it's not true. So how we would write this pattern in a less confusing way? How about this? Y is equal to ax plus b, where a and b are any real numbers. Then this way of writing down the pattern determines the equation of a line on xy coordinate plane, right? It's also a formula. So what is confusing about this formula? Just too many letters, right? And so it's normal if you feel intimidated. But actually this formula means that a and b are just some numbers and they're fixed, and whatever for different pair of numbers you will have a different line. But the whole idea of formula is to capture the essence of a pattern in mathematical expression, right? So I think we're doing a pretty good job here. So we just need to get a little bit more comfortable with formula. Okay, so plural of formula is formulae, and it's completely okay. Some people say formulas. It's kind of making it more English even though the word is not English. Okay, let's look at the following pattern. What do we see here? X in some power. And the power would be 2 here, 3 here, 17 here. So how would you express this pattern? It looks like if I would write x to some positive integer number, that pretty much covers, right? I could also write integer number, but I just wanted to be a little bit more specific. So if I write x to integer number, this is also a possible pattern, right? It would be also correct answer. Okay, so, but since I am on some positive integer number, it also reminds me that instead of this, I could say natural number. So I could actually say x to the nth, where n is a natural number, right? And that would be a good formula to describe this pattern. How about if I will look at this row of numbers and I will ask you what number should be between 9 and 25. And you can see that, yeah, you need to recognize what kind of pattern is encoded here, right? And then you can guess which number should be there. Okay, so what's 1 and 4 and 9 and something else? What is special about these numbers? It looks like they all are squares. So you do have to recognize that squares are kind of more interesting numbers than numbers that are not squares. And maybe cubes are also more interesting numbers, right? So you need to have relationship with numbers in order to catch on the patterns. So this is 1 squared, 2 squared, 3 squared. So I would guess it should be 4 squared here. But let me check further if the pattern holds. Is this 5 squared? Yep. 6 squared, 7 squared, 8 squared. Yeah, it works. See how 121 is 11 squared and 144 is 12 squared? So I guess we caught on a pattern. So the number that should be in here should be, since this is 3 squared, that should be 4 squared. So let's write it down. It should be 16 because 16 is 4 squared. And the pattern that would describe this row of numbers is n squared, where n is a natural number. Why natural? No, because I don't see any negative numbers here. Well, I shouldn't see negative numbers because any integer, negative integer will still be positive, right? And squared will still be positive when n is a negative integer, but there is no 0 here. So if I would just stick with natural numbers, that would be a fitting description, right? Okay, and it's also the smallest set of numbers. So I would choose to go with natural numbers. Okay, now I'm sure you're tired. This is just, we're almost there. So what about the following expression? Is there a pattern that you could recognize? And I was hitting for the difference of squares here, right? So the pattern is a squared minus b squared, that we can factor out as a minus b times a plus b. So you can see that a is x here and b is 5 here. So we can break it into x minus 5x plus 5. And then when we look at this pattern, it's backwards difference, factored difference of two squares, right? So it's kind of, when you remember this formula, it's a shortcut. So it's a convenient formula to remember. Note also that a common error to factor these two squares is to forget that this number is also square, right? So it actually 81x squared is actually 9x squared, right? So a is 9x, not 81x, right? Okay. Another common mistake is that people expect a similar behavior from the sum of two squares, but you are stuck with sum of two squares. It just does not factor. You'd think that maybe it would factor into a plus b times a plus b, but let's compute. So that would be a plus b squared, right? So let's multiply. So we are getting a squared plus ba plus ab plus b squared. So we will get a squared plus 2ab plus b squared. And you can see that a plus b times a plus b is not that, because a mixed term is missing from this expression, right? We should have it. Okay, for example, 2x plus 1 squared, if we have to compute it using the shortcut formula, so the shortcut would be this is equal to the last thing. We would have to either multiply, but which is kind of a little bit longer, but using the shortcut formula, you jump from here to here, so the first term squared plus 2 times product of mixed terms, right, 2x and 1, and then plus the last term squared, so we end up with 4x squared plus 4x plus 1. Okay. What about a minus b squared? What would be the shortcut formula? I'm sure you know it, but you can also derive it. So, and then you will remember it better. So that would be a good exercise. Okay, the end.